Great. Hello. How are you all doing? Firstly, big thanks from everyone at Speechmatics for having us here at UKIS. Personally very exciting for me to be here again. I went to the one in Sheffield in Edinburgh 2 years ago, and there was a very memorable moment where we were at the Cayley afterwards, and we've been trying to show off all our ASR the whole time. And so me and Will were sitting in the restaurant or cafe area. One of the PhD students or the master students from Edinburgh came up to us and wanted to try our Japanese model. And we got it up on our little phone and got on the portal and loaded up Japanese, and the connection wasn't great, and there was a Cayley going in the background. And the fellow sort of spoke Japanese, which neither me or Will sort of understood, and looked at the transcription and looked at us and looked at the transcription. It's perfect, and I was, oh yeah, it's amazing. So that was a great moment, and so it's great to be back. And obviously we're based in Cambridge. If you don't know much about Speechmatics, our founder Tony Robertson is sort of a professor here, did his PhD here, and so it's a really nice moment for us to be back and to share some of our thoughts and show off our transcription, and that's really awesome. So big thanks for that. So a bit of a background on me. So I am a team leader at Speechmatics. I work in the representations team. We do a lot of representation learning, self-supervised learning. But the nice thing about Speechmatics is we do lots of different things. So it's been really interesting being here and seeing all the kind of new things that have been worked on. I guess one question you might have is what does this mean? And that's a very fair question. So one of the goals we have at Speechmatics, and something we can talk about, and I think is a very sort of important goal, is that we want to kind of understand every voice. And it's quite pithy and can mean lots of things, and that's kind of the point. That's how I kind of want to frame this talk, is sort of, what actually needs to be done to understand every voice, and that's sort of with all the nuances that you can kind of comes with that. So, we took a great keynote this morning, just now, on sort of prosodic intent of speech and all the nuances that come with that. And that definitely is included there. Then the sort of the ASR and kind of understanding lots of the voices across the world, many languages and many backgrounds as possible is also very important. So that's kind of the thrust of what I wanted to start the conversation with today, is kind of how what does it take to understand every voice, if taking that kind of goal very seriously, which I think is important. So I thought I'd just start off with kind of like why we have this framing. Is this useful framing? Is this a worthwhile framing? Why do we set this up? So this is an example of the goal website. You can see this now. This is sort of our, kind of initial attempt at this goal. High accurate transcription and some nice translation, and it's going to help understand people's intent. Kind of communicate across language boundaries as well. That kind of brings us towards this goal. Do we want to continue pursuing this as a worthwhile thing? Hopefully you think so, and I definitely think so too. And it's kind of a nice, sort of ever-moving target that we can kind of aspire towards and push towards. And so that's how I kind of want to frame this. And I'm going to kind of bring up sort of 3 areas of how we do engineering and how we do speech recognition at Speechmatics, and kind of more broadly as well, not just speech recognition. That kind of within this framing, that kind of. And then reflect on some of maybe the trade-offs that we make with this framing and why those things are important to us. And hopefully that's interesting and to share with you. So that's essentially it. So these are the sort of 3 framings I'm going to look at today. That we're kind of, there's lots of things we're proud of as Speechmatics, but some of these are some of them. And I think kind of this guy gives us kind of narrow kind of section of topics to talk about today. So one of the things we've been really happy with is our sort of language coverage. So we support 50 languages at the moment. That keeps getting added onto. And there's lots of other models, lots of other places that do lots of languages, but we do them pretty well. And we want to continue doing that. And obviously that's a very it's a big part of how you understand every voice. Is you want as many people to engage with your technology as possible. You want it to be hopefully very good as well. And then finally, kind of another bit that is related, but maybe not exactly the same, is sort of high accuracy across many domains. And the reason I sort of bring this up is maybe a specific point to make as well there, where sort of the kind of the sort of areas of speech you could be good at, even within language, it is very, very diverse, as you may well know. And the amount of kind of actual sort of evaluation and thinking about how good your models are has to be kind of very, very solid, and it's always not good enough. Finally, I want to kind of highlight this kind of final point, which I think is a massive discussion as well, which is sort of how do you make ASR cheap, quick, and easy to use? Like what is the state of technology today, which is, kind of means how do you address that trade-off as well, or how do you kind of achieve this? So firstly, I just want to talk about sort of language coverage and how we kind of think about that. So this is our list of current languages we use, is 50 there, in terms of translation as well. We're fortunate to have been a company around quite a while, and we sort of spin up languages, call them spin up, because hopefully we do them quite quickly as well. Languages are quite a few every year. And so, I guess the kind of where I want to come with this slide is that this is quite a lot, and to manage this kind of number of languages and to kind of make improvements on all of them is kind of quite a difficult thing all the time. You can imagine sort of there's a file somewhere in our kind of internal code base that has a list of these, it has all the attributes associated with these, and all the model files that can be associated with these, and it's just it's a lot to deal with. And so, over the years, we've had to really kind of think about how we introduce new models into our system, how we manage those, and see how those kind of propagate down to every other language. We've got, there is a good blog from our website on kind of recently released Persian. I would have a look at that if you're sort of interested in like what this actually kind of concretely means. I think one of the things that kind of is really noticeable here as well is sort of spinning up a language. One of the things people talk about in software engineering all the time is sort of automating things. And you can imagine the naive Speechmatics sort of machine that you kind of turn, and we put kind of Persian in, we put a lot of data in, and that kind of turns out a language, and we just ship that off. But a lot of the kind of the work here is like not automated in the sense of I've got some sort of set of code I run that kind of evaluates these models and does a good job, but it's actually sort of knowing what it's kind of having the muscles internally in the company to know when a language is good enough, to know how to kind of ship that out, to know who to talk to. We don't have many people at companies who speak Persian. We have to go out and find those people and talk to them and see what they think about the model. And so, kind of from the slide, what I want to sort of emphasize is like how if you want to understand every voice, this is like it's kind of not a small task. And to do that, you kind of need to work with muscles, and you kind of need to get good at this kind of thinking about how do you internalize a new language in your system and kind of maintain that over years. And so that's how we kind of approach languages. We kind of think of it as like yes, we need to automate it, but also we kind of need the internal muscles of the company to do a good job. So this was kind of another sort of separate point as well, and I wanted to talk about this. I think it's super interesting, and in some ways I think about evaluation as never being good enough. You always sort of find the limit and then need to find more things. And so this is what I pulled up from papers with code on liberal speech test other. So this is a sort of internal, kind of maintained state of the art on liberal speech test other. I think people made progress. It's great, and it's a very useful benchmark. And then I thought I'd put Speechmatics on there. We're not very good. Well, we're okay. But I think the interesting, kind of the point I wanted to make here, and what I want us to kind of think about is, sort of convey is like, actually, this is not really concerned to us, or at least it's quite a small part of the picture. We kind of have these, we almost have sort of 40 or 50 internal test sets we evaluate each time we have a new model, especially for English, maybe even more. And we have a liberal speech test other in, and we see changes in that, but then we see changes in 49 other test sets all the time. And so, actually, if you imagine when we're kind of developing new models and we're trying to kind of consider them for putting in our new product, kind of benchmark stuff these aren't good enough, or sort of only give us kind of small slice of the picture, and actually it's pretty complicated as you read it more. As I'm sure you all know. But I think it's interesting to look at context, and the fact that we're actually, maybe back in 2018, 2019, we're on this test set, but it really, in practice, we think we're the best. We are the best. So I thought I'd put some context here as well. So we have an internal database where we store, we evaluate on a test set and get a word error result, and we put it in our database. So we had 16,000 of these entries put in this last month. This is, we've done a lot of evaluation for this, and this is not a normal month, but that's the sort of scale we're thinking about, right? This is sort of 50 languages, each language has a certain number of test sets. We're training so many different models. So yeah, it's a ton of evaluation, and we're constantly, this is constantly something you have to push up against. This is, I've been in so many meetings where you've been like, can we trust this result? We've not made any improvements, things like that. Okay, so I had 3 boxes in the triangle. One of those was how do we kind of maintain and think about kind of deploying new languages and what muscles we need to grow there. The other one was sort of how do we think about accuracy across different domains. And we've hopefully spoken, made it clear with. We do a lot of testing. So the final thing I want to talk about was this kind of speed, price, efficiency point as well. And it's a very scientific graph. I think maybe it's just sort of something we think about a lot of the time as well. Is we need to run these models, we need to run them efficiently and cost effectively, and maybe a 2 billion parameter model is just like ridiculous if we for a 2% word error gain, maybe that's not good enough, and we could do so much more efficiently. But we're at a stage now where a lot of kind of the cost of compute and the availability of these of GPUs to us, it really makes this trade-off very easy for us to take. It's very easy to grab that next 2% of word error rate, and in 2 years those models are going to relatively seem very tiny. And so another thing I kind of wanted to convey as well is like when we're developing models, it's really not about trying to hit some interesting maybe it's about hitting some interesting Pareto frontier of best compute and best word error rate. But we're in this phase of just models kind of scaling up. Everything's getting cheaper. We can run it sort of, we fortunately have enough traffic where we can really process a lot all at once very efficiently and very cheaply, and provide ASR to a lot of people. And so, this is a great trade-off for us. We want bigger models, we want better models, even if in reality you get very close with smaller ones. So my final point, I don't think I have much time left, so hopefully we're good, is that, and it's a bit more of a kind of engineering point as well, so hopefully this is a nice, interesting thing to dive into, but when you're running these models at scale and you're part of this big ASR pipeline, it's nice to have, you can imagine we serve a lot of different languages, different customers all at once, and we need to make those very efficient. And it's nice to have big, large agnostic models, language agnostic models, task agnostic models, things like that. And so these kind of foundational models are always a very key part for us as well, because we want to serve as many tasks as possible, we want to serve as many people as possible, and these kind of economies of scale really add scale up. And so this is a really important thing for us as well, and that's something my team deals with a lot personally as well. So that's most it from me. Maybe it was a sort of whistle-stop tour of kind of random parts of, important parts of our ASR pipeline, how we think, how we develop new features, new languages, things like that. I kind of wanted to convey as well, sort of, there's many trade-offs you have to make when training these models. You kind of have to, you want to create something great and something important. But when you're in kind of the setting we're in, it's maybe it's quite a unique place you might approach these things. So you might have to, you're very willing to take these trade-offs of bigger models, better models. You're very willing to you're always looking to kind of unify models into things that can do kind of multiple tasks at once. And you're always kind of working on this internal sort of how good can we spin up new languages, how good can we evaluate them as well. I think that's it from me. So thanks very much for listening, and hopefully we'll have some questions now as well.